Good afternoon, everyone.
Hello, everyone. Yes, I can hear you, Sanchan.
Yes, Venkat, you can start.
Yeah. Okay. Hope you are safe and healthy. On behalf of ISFMU students, I welcome all participants to the fifth day of Limit Camp. I have great pleasure in welcoming Professor Alok Kumar to this platform. Professor Kumar had already given a lecture on Sophie Germain identity yesterday. With great honor, I welcome him back to enlighten us on the x plus 1 by x expression. The x plus 1 by x is a simple innocuous expression which can be at the heart of many beautiful problems. Today's talk is today's talk has this expression as a starting point and will then involve problems wonderfully woven around it. Now over to you, sir.
Okay.
Yeah.
Okay. Thanks, Venkat. Thanks, Venkat, for introducing me. So,
Welcome, sir.
yeah. So, yesterday's was okay. Now let us start today's lecture. So let me quickly share the screen, and then I'll. So first of all, a warm welcome to everyone to the Limit Camp. These guys have been doing a great job. The student community of ISI, and I have the pleasure to know them for a long time, and some of them have been students as well. And all of you, I congratulate you at the outset for having performed so well and reached till this stage. So try to make maximum use of whatever activities are like allowed for you, or whatever activities are presented by the people. Okay, so let me now just quickly share the screen and then we'll begin. So I mean, this is the way to. Is the screen shared now? Can you see?
Yes, sir.
Okay, so let me. So right now there is a black just background, right? That you can see. Yes.
Yes.
Okay, let me. I'm trying to import a document from my laptop. Just allow me a moment. Yep, we are here. Sum of a number, it's reciprocal. Yep. Okay. So first of all, this is actually the audience last day was, I think it was 8, 9, 10, 11, 12. Today we have got A. So A means like 8 and 9, or what? A means what? 8 and 9 today? Grade 8 and 9, right?
10.
8, 9, and 10. Okay, good. 8, 9, and 10. So that's why I have chosen something much simpler. Okay, that's simply x plus 1 over x. Means sum of a number, it's reciprocal. It has got amazing properties, and you will soon learn that it even leads to induction and recurrence. So let me present some kind of theory behind it, because I always like to balance my class. Although you see in lecture, it's very difficult in these kind of lectures, because we just get 1 hour or say 1.5 hours. But still, I try my best to give you some kind of insight also, and some kind of theory, and so that you know what exactly is the idea, and then of course see the applications of it, right? So that's the way I try to present my classes, and I try to be eclectic in my choice. I mean that I take from diverse sources in respected learned journals and learned magazines, so that you exactly get the real feeling of it, the thrill of it, that okay, this is how contest writers are using these concepts when they want to test you, when they want to rather test you, of course, is the more examination type word. Say they want to make you feel the thrill of it. Okay, this is so beautiful, this can be so interesting. So it is important to include some examples from some competition also, and our RMO also. Okay, so first let me just tell you, this is one question you are seeing here. It is flashing here. I'll just do some kind of results first. So let me add one page here, insert one page just, and then So if you write x plus 1 over x plus 1 over x, and so not right, like, let's start alpha plus beta. Suppose we have got some numbers alpha plus beta, this one, and alpha beta, this is given. Then you know that I can, this is just dependent on identity. I can write alpha to the n plus beta to the n. You can verify this easily. Is alpha plus beta times alpha to the n minus 1 plus beta to the n minus 1 minus alpha beta alpha n minus 1 plus beta n minus alpha n minus 2 plus beta n minus 2 alpha to the n minus 2. Alpha beta are some numbers, no real complex, I don't care. So alpha to the n plus beta to the n, that equals alpha plus beta times alpha to the n minus 1 plus beta to the n minus 1 minus alpha beta times alpha to the n minus 2 plus beta to the n minus 2. And I can say that n greater than equal to 2, right? Because there is no point in going this kind of thing. So n greater than equal to 2. Now, this you can interpret also as kind of quadratic equation or recurrence, right? Say, if you have got a quadratic whose roots are alpha and beta, so that can be given by x squared minus alpha plus beta x plus alpha beta is 0, right? So how one method of doing this is that just verifying that somebody gives you this and you ask him that hey guy, how it comes? Then he says, don't worry, just multiply and expand and simplify, and you will find that okay, right equals left. That indeed is true. Okay. The deeper meaning is that if alpha and beta are roots of this equation quadratic, then what I can do that let me write some alpha plus beta as some good notation sigma 1, alpha beta is sigma 2. Remember, good notation is a sign of a good mathematician, right? You must be choosing good notation S1, S2, and make them your friends for life. Make it sigma 1, sigma 2. Always let it be ritual. No, unless it is given in question something else, then you choose S1, S2. No, English has got so many letters, even Greek you can use. Okay. Now, so this is this one. So I will say that alpha satisfies alpha squared minus, I will write here now sigma 1 alpha, and plus this is sigma 2 equal to 0. And so I can multiply this by any number. So I can multiply it by choose to alpha to the n minus 2. So this is alpha, and remembering the mind that this has got meaning. So n greater than equal to 2. So alpha to the n minus sigma 1 alpha to the n minus 1 plus sigma 2 alpha to the n minus 2 equal to 0. I can bring things on the right side. So alpha to the n, it's sigma 1 alpha to the n minus 1 minus sigma 2 alpha to the n minus 2. And there is nothing great about beta. Beta is same as alpha. So I can play the same thing for beta, and same tune will give you beta to the n equals sigma 1 beta to the n minus 1 minus sigma 2 beta to the n minus 2. N greater than equal to 2. Let's keep writing. This is very important to write always. Now, so that you keep track of it, and when you are doing maths, then mostly now you are now you people are learning maths, right? You are applying different exams, so you want that you must be accurate in exam. Means you may not lose your credit just because some silly mistake, right? At research level it does not matter, but here it matters. So inculcate good habits. So just add them. So when you add them up, alpha to the n plus beta to the n, it's sigma 1 alpha to the n minus 1 plus beta to the n minus 1 minus sigma 2 alpha to the n minus 2 plus beta to the n minus 2. In a way, what we have done is that we have arrived at as a recurrence for this one, right? So somebody if writes a sub n is alpha to the n plus beta to the n, and n greater than equal to say 0. For 0, you define a naught is 2. Good enough, right? Even if roots are 0, does not matter. A naught is 2 because we are not saying 0 to the 0. This you ponder later. Okay, so a naught is 2. You define something, and then a1. If you have a doubt, a1 of course is true. So a1 is alpha plus beta, and then something a2 is alpha square plus beta square. So you know that it is a recurrence relation. This is a recursion which is said an is sigma 1 times an minus 1 minus sigma 2 times an minus 2, and let's write n greater than equal to 2. So it means the moment I give you two seed values means say a0 and a1, because it is saying that from the term 2 onwards I can express everything in terms of the previous two terms in some combination, linear combination. Okay, so to begin the recursion I can give you say a0, and I can give you say a1. a0 is always known, right? And I can give you say a1, and then I can get a2, then I can get a3, and so on and so forth. So that's recursive meaning here, recursion. It also you can say that this is kind of an plus some constant an minus 1, if this is constant given, and plus an minus 2 equal to 0. So it is linear recurrence relation, right? Linear, and then constant coefficients. They are beautiful because we know much more about its solutions. And also when you read differential equation later, so you will study something called that linear differential equation with constant coefficient and homogeneous, of course, because 0 is there sitting right now on the right side. And so you will relate with that. Okay, this is the same thing. So everything is going on the same. So either this one for class 8, because I just told you one identity, just like your teacher tells you alpha to the 3 plus beta to the 3. So I derived one recurrence also supporting it. And so we find this one alpha plus beta. Now, if this is known to me, alpha plus beta and alpha beta, which will be known if even if this is known, this is known because I can write alpha squared plus beta squared is alpha plus beta squared minus 2 alpha beta. So it just depends how I give. I can give any two terms. So say that two things are given, and then you are rest doing this one. So this is your recursion. This is what we will do. Interesting thing happens when I set beta is 1 over alpha, right? Beta is 1 over alpha, or okay, 1 over alpha. So now this is alpha to the n plus 1 over alpha to the n, and that is alpha plus 1 over alpha n times alpha to the n minus 1 plus 1 over alpha to the n minus 1, and minus this thing becomes 1, alpha to the n minus 2 plus beta to the n minus 2. So things pretty much get simplified. And then the like our x plus 1 over x takes birth here, right? X plus 1 over x, the baby has arrived, x plus 1 over x, like this. Okay, and we will see many more applications of it. I can also generalize it. I mean, I will do it later. Generalize, I mean that I can show you something like in RMO problem, they use something differently. Okay. So RMO, you can check the problem RMO 2019, I think, or 2020. That is one really good question was there. And then one question I will solve today also. So any question till here, what we did, I assumed nothing from you. I just started on a clean slate and I said that, look, alpha to the n plus beta to the n can be expressed in terms of two predecessors, alpha to the n minus 1 plus beta to the n minus 1, and alpha to the n minus 2 plus beta to the n minus 2 with some constants thrown in. This is and some suitable conditions on n given that n starts from some point onwards. That's what I did. Any questions from the audience? And anyway, this will be shared, so you can, of course, in the way the teams Sanchayan and Ankan other people have done that, they're uploading it also. So I mean that you can see it later also if some things are not clear. Okay. So now let me go.
Sir?
Yes, please tell.
Can you explain how you got? Can you?
I will write a step.
Alpha to the n plus 1 by alpha to the n.
This one here. Here what I did, that this is my identity. I set here beta equals 1 over alpha. Means I take beta to be reciprocal, right?
Sorry.
So it is actually good one. You can always ask. I always encourage asking, right? Because first time you are doing, so first time it is really, people have to learn so many things. So we have to be patient with ourselves also and with students also. So this is like this is the thing we will get. Okay. So I encourage whenever you learn something, keep writing. I mean that you write it 3 times, 4 times, 5 times. No, when you are doodling or something, no. So okay, this, and just marvel at you. This is really lovely, alpha plus beta, and this one. I learned it in class 11 and 11th, I think, or yes, 11 or 10 maybe. Okay, maybe 11, because when I was preparing for JEE Advanced, that time there was no JEE Advanced, so say IIT, and then I can really feel the thrill that when I saw it, that okay, this is like really interesting. I multiplied that, yes, it matches, correct. And then I thought that okay, it is applicable in many problems. So I just picked it up, right? It is not that, no, but right now, but today there is a whole lot of training going on. That is good also sometimes bad also. Okay, but then it's like that. Okay, it's like now things are being served to you on the platter. No, you just have to test it now. No, but sometimes people refuse to test also. That's not good. Okay, now, so even whenever I see this one, I will be reminded of my class 11. Oh, I remember that. Okay, I did this and I verified. I thought it was really good. Okay, now see this question, right? So you have to find this kind of thing. I mean that this is in our language, what is happening here. This question is that you are given x plus 1 over x is negative root 5. You
Sir,
can
is
divide
the
by
answer 5 root 5?
answer I have not checked. Let me check. Let me just like begin first, and then we can check. It should be easy, not difficult. So first of all, please listen to me out carefully. So first divide by x. We can divide. We have to justify dividing. So we can say that okay, x is 0 is certainly not a root, because if you write 0, then left is 1, right is 0. So 0 is not a root. These things will be effective in kind of subjective things, right? That you are justifying things, so people will like it. So if x is 0 is not a root certainly, and so we can divide by x, and so x plus 1 over x is negative root 5. So now it is time, and this of course I'll write. So x5 plus 1 over x5 is negative a, and so I want this number. I want minus a. So now you are okay. Now what you are doing is that now you are saying that okay, I will ask you all also, but let me set up till some point. So right, because some people will be really new, so I really want to reach out to them. So see, now you are saying that okay, I have been given x plus 1 over x, and then I have to reach to x to the 5 plus 1 over x5. This is what we say, that I have to reach till here. Okay. So means how to express this one. You know that x plus 1 by x to x squared plus 1 by square you can read easily, right? We have got identity for it, ready-made. X cubed plus 1 over x cubed. x4 plus 1 over x4, not readily, but then we can do these things. Then x7, x8. Theoretically, I can reach anything. x237 plus 1 over x237 if I had enough time, or there is some computer or these days, so we can reach it theoretically. That's what this problem wants. So it becomes now recursive, right? Because this is the way I showed you this one, that previous, next one. See, the way I showed you this one. So it means I will immediately go to this one. So I will say that, okay, if I write a1 is x plus 1 over x, and I define an, my a sub n is x to the n plus 1 over xn. So my question is that given a1, you find a5, and of course a0 is known. So a0 is just 2, right? And so I can write here that the way I told you, that x to the n plus 1 over x to the n, it was, I encourage you always write this first step, x plus 1 over x to the n minus 1 plus 1 over x to the n minus 1 minus x to the n minus 2 plus 1 over x to n minus 2, and then write in terms of an. So a sub n, that is x plus 1 over x, that is now given. So I will write that is negative root 5. So that is negative root 5. And this is your a sub n minus 1. And minus, this is anyway 1. You understand now, n minus 2. And I'll write n greater than or equal to 2. So now this is my recursion. And I'm given a0 is 2. And a1 is negative of root 5. Negative of root 5, if I not make a mistake. And then I can calculate successfully a2, a3, all I can keep calculating. Is this approach clear? That how we reached? Now you can tell the answer now, someone, if you have done.
Yes, sir. I tried 5 root 5.
Yes, sir.
I think 5 root 5 is correct. 5 root 5 is really correct. Okay. So 5 root 5 is correct. Good. So a2, for the benefit of all, let me write a2 is like I write minus root 5 times a1 and minus a0. So minus root 5 times a1. Don't make a mistake. It is again negative root 5, and minus a0 means minus 2. So 5 minus 2 is 3. Then a3. So a3 is 3. No, like you are saying that okay, this is not 3. Negative root 5 times predecessor 3. This one, and minus. So this is a3. And minus again a1, and that a1 is negative of negative root 5, and so you are getting here negative of 2 root 5, a3. Then you will get a4, and then finally you will get a5, and a5 is negative of 5 root 5. I think you should get this, and then somebody answered it correctly, that the one a5 is negative of root 5. Okay, and so a will become 5 root 5, correct? That's what you are saying. Okay. Yes, someone got it right.
Yes, sir.
5 root 5 is the answer. 5 root 5.
Yes, sir.
Yeah, minus 5 root 5.
A is minus 5 root 5, right? Because a5 you got. Okay, that you can check. So a is negative 5 root 5 you are getting. That's all.
Yeah.
No, I think a is 5 root 5.
Positive only.
A is positive 5 root 5.
Correct, because we get a5. No. So A is 5 because already negative is here. So that is matter of choice, that what you can check. So this is there. This is what we get by using this one. Okay, I will come back to it later. Okay, to ask that, to make some connections later. That okay, what is A3, A4, A5? I mean till A5 and A4. A5 also is good. I have seen many questions like, in fact, I was looking at some questions of HMMT. No, Harvard Mathematics Tournament. No, Maths Meet Tournament, this one or other. I found that they use these things also very cleverly, A5 or something. Again, same kind of thing, just like limit. No, there are also student communities around the world, and you will find that they are also doing some problems. Okay, so this is one. Let me go to next one. Okay, this I'd like you to try this one. It is just written in the term of, see, somebody can write, let a positive real number and let f r2r be a function, something defined, let f. But then it does not be a question of function, right? It is actually algebra. So they're just packaging. I told you yesterday also, okay, that normally they will be testing something. There might be some kind of presentation that, okay, you're asking what function? We are just using some kind of simple algebra like that. So please do it and let me know. I can give you 2-3 minutes for this. It is really presented well. This question is presented well. T2 is the author of this problem. He kindly let me know about these things. Does someone have a plan? Actual calculation might take time, but does someone have a plan?
Yes, I was thinking about.
1% first.
So we can use a to the power 2 by 3 plus 1 by a to the power 2 by 3 to find a square by 1 by a square because it's just the cube. And from a square plus 1 by a square, we can find
you
a
want
plus.
to find a square plus 1 over a square. You can find. Okay.
Yes, sir. From there we can find a plus 1 by a. And from there we can find a cube plus 1 by a cube, and then we can find a 3 by 2 to the power plus 1.
Yeah, that looks all right. That looks all right. I mean that from here you want to find, you will cube it, right? Means this is something
Yes,
something 3. So I just showing like visually something 3. So you reach this stage, this path, and then from here you come down. Okay, you can come down now. You know how to come down, and then you can go up. Okay, so good. It looks like good plan. Up, down, up, like that. Okay, good one. So something along these lines people can experiment. Now I would say one more thing also can be worked. So a2 over 3 plus 1 over a2 over 3 is there, is 1 plus 2 root 2. From here I can come down to a to the 1 over 3 plus 1 over a to the 1 over 3, right? Because this I can come down, correct? This is t square plus 1 over t square to t plus 1 by 2. That is the root here. From here again I can go to cube. So again same thing here. So here we match, means this is 3. So I'm here not 3, here just squared. So this is 3. And again, I reach a plus 1 over a. And then again here 3. I reach a cubed plus 1 over a cubed. And then again come down and we will get this one. So that's, so both plan can work. Let me start you with this plan little so that we can understand. And of course, I'll tell you the answer so that you can check later also. So if this is there a, so a to the 1 over 3 plus 1 over a to the 1 over 3 is squared. That equals a to the 2 over 3 plus 1 over a to the 2 over 3 and plus 2. And so it is given 1 plus 2 root 2. So this becomes 3 plus 2 root 2. And that's a perfect square. It has been so designed. So a to the 1 over 3 plus 1 over a to the 1 over 3. And I can take 1 plus root 2. Reason being that we are given positive real numbers. So of course, negative is killed. And we get this 1 plus root 2. This one. And so, and then from t plus 1 over t, I can get that t cubed plus 1 over t cubed is t plus 1 over t cubed minus 3 times t plus 1 over t. This one, 3 times 1 plus t minus 3 times t plus 1 over t. And so you understand that now that this a plus 1 over a, that equals 1 plus root 2 cubed. So I'll take 1 plus root 2 here only. I'm taking this common. And so 1 plus root 2 whole is squared and minus 3, right? Means I wrote this as t plus 1 over t to lessen the calculation, and t plus 1 over t whole is squared and negative of 3 I took. So this is this. Now it is easy because 1 plus root 2 and number has been chosen wisely so that there is less calculation. So you get 1 plus 3 again, 3 gets cancelled and you are getting 2 root 2. And so you are getting 4 plus 2 root 2. That is your a plus 1 over 2. From a plus 1 over 2, you can climb up to a cubed plus 1 over a cubed. And then after you get this one, can somebody tell what is a cubed plus 1 over a cubed? Let me engage you also. What is this one? Given this, someone quick.
The number or
Number, a cube plus 1 by a cube.
sir, I'm not sure if I'm getting 148 plus 106 root 2.
Okay, so you must trust yourself. 148 plus, let someone else also answer this. What's your name?
Sir, Aryan.
Aryan. Aryan is getting this one. Non-Aryan? Yes.
Sir, I am
Nobody?
also getting 148 plus 106 root 2.
Okay, what's your name?
Sir, Biboshan Bishas.
What? Please tell again.
The Biboshan.
Bivoshan is. Can you spell it? Can let me write? Can you spell it?
The B-I.
B-I.
B-A.
B-A.
S-W.
S-W.
A-N.
And how do you pronounce it? Biboshan. What?
The Biboshan.
Biboshan, right? Biboshan. What does it mean?
So it means the sun.
Oh, good. Good. So, okay. So my knowledge is increased. I'm interested in language normally, and I ask my students name especially. And of course, many of them don't know the meaning of their names. At least you know. That's a good thing. Because sometimes when you go to some interview, they ask you just for some small things like where you are from, what's your name. And if some name is something like they have not heard of or not popular, they can ask you that meaning or something. So good. Okay, Bivoshan, good. So this is this. So this, I think it is correct, a cube plus 1 over a cube. And then of course you will add a 2 to it. So we will get a cubed plus 1 over a cubed and plus 2, that equals 150 plus 106 root 2. And then of course, like root of them, it will be answered. Okay, you don't get good roots, so just you will have the answer as square root of 150 and plus 106 root 2, which you can check later also. This you should get to the answer. So see, it's an easy problem, but then still it has also got its own charms. No, the like simplicity has got its, a lot of things are there, and you make a bridge like this one. You make a bridge that how to go here and reach this point. Okay. First, it looks like, see, now understand that this is nothing to do with 2 by 3 and 3 by 2 is just for the satisfaction of the mathematician, right? that somebody may think that, okay, he's asking FR and 1 over R or something, but nothing like that here, right? It's not that 2 over 3 and 3 over 2 has some kind of relation. So they are actually red herrings, right? To mislead you somewhere, that you may think of some nice method that maybe let me relate F3 by 2 to F2 by 3, not do all this. But sometimes the idea is that only, nothing else. Okay. Okay, so let me do this one also. This one is a different idea. Of course, we will have basic is that only, but then can someone just tell the idea, if because this 8, 9, 10, some people might be knowing that how to proceed. I just want one word that this applies. This I will do by this one.
Sir, the root 5 plus 2 and root 5 minus 2, they are conjugates of each other.
Oh, good.
So we can proceed by contradiction, maybe.
Okay,
Assume-
good, very good contradiction. And then what will come? What will help us in establishing the claim?
So maybe we can equate it to P by Q and try to do something.
I think there is one technique. Like, of course, it is just like you can guess also that this. Actually, you will get into induction here now. That's the charm. But good one. See, first of all, I'll write this x as, I will tell x as nth root of root 5 plus 2, some number. N can be any fixed number. N is 88, 90, whatever is there. So naturally 1 over x, that somebody said that it is this one, 5 minus. So square root of 5, square root of 5 plus 2, and the square root of 5 minus 2. So that is this 1 over x. Like, so we have to prove that x plus 1 over x is an irrational number. Irrational number you have to prove. Okay, irrational number. So what I do that, okay, so I write first x to the k plus 1 over x to the k. This I write as ak. This is my ak, right? This is some sequence. So of course, by this one, I get that ak is x plus 1 over x times ak minus 1 minus ak minus 2, and k greater than equal to 2. This one, n greater than equal to given also, k greater than equal to 2. And then because this is known, because you have assumed this one, x plus 1 over x, so call x plus 1 by x as say call it some kind of p, something p. So this p is known. This p is known, p ak minus 1. Because n is fixed, right? N is fixed. N is 100 or 200 watt. So for some fixed n, that's why I'm using here k, not n right now. So this is n minus ak minus 2 is okay, ak minus 2, because this was 1. You remember this was 1, and so it became like this, ak minus 2. Now induction applies. And which induction applies here? So induction has two forms. One is called this one. One is called weak induction, which is called strong induction, right? Here a strong applies, right? Means you are assuming more than this one. In induction, what we assume here? No, normally we assume that, okay, base case say A1 is true, A1 true, A1 is true, and you are saying that AK implies AK plus 1. The truth of AK implies AK plus 1. Then this is AN is true for all n greater than equal to some base. There is other kind of induction in which we are saying that A1 is true. A1 is true. I will tell 3 type of induction. A1 is true. A1 first holds. So A1 is the base case. So base is true. Base is true. Here, this is called inductive hypothesis. This is called, those who have not read also, please understand. This is called base case. No, we call base case. This is our basis for induction. No, for example, if I want to make sure that you understand something or not, so somebody can make base case that okay, no, like just now that boy, that what was the name? Bibosan understands. So Bibosan is base case mine. No? And then I can proceed that, okay, if he never understands, and then again never, then I assume that everybody in the class understands. Okay, so this is my base case A1. So this A1 is true. Sometimes I assume this one. This is one basis. So base case induction, and this is so this is called inductive hypothesis. Okay, so AK is AK plus 1. Under this assumption, you said that AK is true. Hypothesis. This implied AK plus 1 is true. Then true for all. No, or sometimes it has been likened to a series of dominoes also. That dominoes, falling dominoes. You can read it later somewhat. Now, A1 is true. Here, A1 is true. In other version, strong version, A1 is true. And everything, suppose, and it is and you have got A1, A2 till AK, everything is true. Means till AK is true. Till AK, you are saying, not only AK, not only AK. This time it is everything less than K, less than equal to K. A1 of course including, to not a problem. So everything less than k is true, and if they imply together that ak plus 1 holds, then we will say that n is again true for all n. It seems that it is requiring, second step is requiring much more. It is much more, it requires much more. It demands much more than the first one. That is why it is called sometimes strong induction. Strong means it requires a strong condition. No, you want something. It is weak. We want just, I just want one person, no, one neighbor. Now I want then, no, all my previous neighbors from some point, they also have been this, and then next I can predict about this. This is called strong induction. There are many variants. One variant is called a step induction. A step induction you will find in number theory courses or a step induction. So sometimes you talk of a step 2 or step 3. Here I can say either this also you will be all right. If you want to use minimum thing, then only A1 will not work. So what you say here, a step induction means that AK and AK minus 1, these two are true. This will imply AK plus 1. But remember, for this to happen, base case now becomes two consecutive numbers, A1, A2. I repeat, first induction is this one that you have been doing always all your life till now you have read, or this also some of you might have done. So this is the first induction, the induction first principle we say. That okay, so base case is true. Let's say base A1 is there, maybe A2 also. Right now base is A1, and given inductive hypothesis means given AK is true, prove that is true for AK plus 1. You have done your job. That induction verifies the claim. Second is called a strong induction. Second variant, a strong induction. Name only is strong, means now the inductive hypothesis is much more stronger. Base remains same. You are saying base is A1, first is true, and you are saying that everything less than equal to something is true. Say every case including 1 up to k is true, and assumption of this, assuming this results in proving or in verifying that AK person is true next one, then also induction applies, and it says that okay, then by the principle of strong induction we have proved that the result holds. Much more strong induction. Third is called a step induction. Here we are not saying that all of them are not these all. You are saying that okay, let's assume that the AK minus 1 AK is true, two previous ones, and use this to prove that AK plus 1 is true. But for this to happen, when you check base case, you have to like prove two base cases. Similarly, if you take three base cases, you will find some good examples of this kind of thing that prove that something cannot be dissected. Or there you will find that okay, you have to prove 4 base cases, and if you prove only one base case, it turns out that other base cases are difficult or tricky, and so you will not get marks for that. So please watch out for those kind of things. I've given you the idea. Seed is planted. You research now on this line. Okay, so I will use a step induction here, step 2. So I will say that okay, assume that AK minus 1 is true and AK minus 2 is true for all k greater than equal to 2 or 3. I can take if base case is 1, then I can take 3 also here. 3.
Sir,
Yes.
how is 1 by x equal to that? Like
1 by x.
minus.
But that is x into 1 by x. No, that is product here.
No,
Here
on
product
top, above that.
Above that x plus 1
On
over
the
x.
left. On the left.
On the left, x is this.
Yeah.
So, that is this one. No, that is their reciprocal. Root 5 plus 2 n times root 5 minus 2 is 1, right? Yes or no?
Oh.
So, I mean, so if this is x, this number is x, then this is reciprocal cousin, right? So 1 over x, right? So x plus 1 over x, and then ak I'm writing. So I'm saying that okay, ak minus 1, ak minus 2 is true, and this implies that ak is true. So you can say that by principle of a step induction, you can say a step 2 a step induction or something. Just read some book in which this statement is given. Okay, or you can assume all also, strong induction also. This will of course not, first variant will not work. No, because only ak minus 1 is not enough. No, you cannot prove. So either you write second, it means much more is required, but you want only 2, still granted to you. And then you don't have to prove in any exam, right? You just have to write. So you can write that by principle of strong induction, this holds. Okay, so now you have proved that AK or AN, I will say now AN, or AK I will say not N is here. You have proved that AK is rational, AK is rational, right? Contradiction was there, no contradiction I've started. Means we have to prove this irrational number. You have to prove. I assumed what? As somebody suggested, assume x plus 1 over x is rational. So if P is rational, then of course second was rational. I can base case will be 2, AK and A1. That you can find that also is rational. So 2 base cases to verify, and then you prove that okay, then it means by strong induction that even AK is rational for all. So you have proved that AK rational for all k. all k greater than or equal to all k. So in particular, now n whatever n may be 1,000, 200, no 1 million. In particular, for k equal to 1 also it must be rational. But then an is something, when you do an, then radical go out, and an is root 5 plus 2 and plus root 5 minus 2, because definition of ak was this one, this one. And so in particular, it is rational for all you have proved under that assumption. Okay, and so an is this one, and that of course is not true because that is 2 root 5 irrational. And so you have established the claim, contradiction achieved. Is that method clear? Our claim, yes. Please tell.
So we used induction on rational numbers. Like we assumed that it is an is rational, and then we got a contradiction while proving an plus 1 is rational. But
No,
so
not n plus 1, not n plus 1 minute. What? No, induction on k, induction on not say this one number, induction on this one power, right? That I'm saying, our claim is I'm proving that ak is rational for all k. I'm proving that define ak is acceptable. Just listen and then you can ask again. So a sub k is x to the k plus 1 plus 2 power k, where x is this number, and n is something given, fixed only. N is fixed, 8, 10, 11, 20, whatever you take. Means this thing, whatever n you take. So I'm saying that ak is rational for all k if x plus 1 over x is rational. Now you can ask. I am proving that ak is rational for all k if you allow me that x plus 1 over x is rational. And that I assumed as part of contradiction. And here
so but in this proof, our base case itself doesn't work, right?
Base case?
So like we
Base
won't
case,
get it is rational for n is equal to 1 or k is equal to 1.
no, k equal to 1 is rational, because we assumed rational. No, we have assumed rational. Assumed contradiction. That's the whole point. See, first only somebody you said no, that see, x plus is irrational. It is irrational. You have to this you have to prove. This is your goal. Prove that. You are saying no. It is not rational. It is not irrational. It is rational. We have to prove it. I am saying assume. So I will write like this: assume for the sake of contradiction that x plus 1 x is rational. This one. Assume this is rational. Are you getting? So base case is assumption. Base case is assumption. That is perfectly fine. Is that clear or not clear?
Yes, okay.
This is again understand. This is you have to prove irrational, but simply we can't prove. So we say that okay, assume. So we will write like that is a mathematician writes. Assume for the sake of contradiction that the given number x plus I've just named the baby x. So x plus 1 x is irrational. Okay. Now let's see what follows if I grant you. So you are saying okay, I give it to you irrational. Now you do what you can do. So you're saying okay, rational. So you're saying that okay, if you give me this rational, then I will prove by induction that everything will become rational. Yes. So ak is rational for all k, but then you will question me, say, but see, put k equal to 1 because n plus 1 I do not know. Again, n plus 1 I don't know, n minus 1 I do not know, but an I know because an radical goes out of the basket, right? So an is this one and say, okay, this an is gone. So, oh my God, an is become irrational. How come? It means that I will say that, okay, but this is not, an is not rational, and so contradiction achieved. If it was 3 plus 2, no, you will not get contradiction. Yes or no, or something else, something different. Okay. So actually Hardy said something very good about it. This one and this about method of induction. I like that quotation. Hardy has written many good things. So there you will find Hardy quotations also because he was good at writing. So he said that just like in a game of chess, what happens? Sometimes you offer your pawn. You sacrifice your pawn. Why? Just to gain something larger, some in the some other point. So you just sacrifice small things. Okay, we do in life also all the things. We sacrifice small pleasures to achieve something big. Then he says the induction. He says the induction is much more. So what is happening that you are just sacrificing. You are offering just one pawn for some larger game. Induction, you're saying that the mathematician offers the whole game. The whole game is up. He said, no, it is irrational for all. So he offers the whole game and then only to win it back. Are you getting? So that's the offer in induction, that you are offering the whole game, or contradiction also. You are offering the whole game. Mr. Contradiction, that you are saying, no, it is not true. So you offer him the whole game only to come back later with vengeance and claim that, no, indeed it is true. So it was a ploy. So I hope you will like that remark and you will remember that. Okay, so this is clear? Yes, guys?
Yes, sir.
Okay.
Sir, in the
Yes.
previous question, can we
Yes.
think about can we find some case such that x plus 1 by x is even irrational? The ak turns out to be rational.
There may be there may be like I'll have to think of some cases something. It's not the no, okay, so there may be. I'm not sure right now. That's what.
So how can we conclude that we can prove that for any such positive integer n greater than equal to, that holds to be true?
No, so that's why I'm saying that here this method works because we found an is to be irrational, right? If n were rational, then this does not work. But that does not mean that problem may be correct or false, right? That depends on the problem. Means if it were not, then method would not. Means by contradiction you aren't able to achieve something.
Yes, sir. Yes, sir.
So, but then it depends on what the problem is. So unless there is a problem, we cannot comment really in a blanket statement, right?
Yes, sir. Yes, sir.
Okay, so let's go forward. And this one, let me do this one also. Let you try first. 3 minutes given for this. Here I would want to connect to first problem. Now you have to climb down. No, sometimes you climb up, sometimes you climb down. Climbing down is difficult. Up maybe sometimes easy.
Sir, I think we divide by root AB on both sides.
That is of course natural.
And then we get x to the 5.
So it's same question, right? T to the 5
plus 1 over t.
Plus 1 over t to the 5 is 5 root 5, something like that. And
Yes.
you want to prove that t plus 1 over t and positive given. So life is simple. Is root 5 you want to prove. No, but then this last time we went here. Last time we climbed up. Remember in number 1, our starting point. Last time you climbed up. So are you having trouble in climbing down? That you check. Because you have to solve some equation climbing down. This is trickier than this. Let me show you that question. We started discussion with this question. I carefully
Yes, sir. I was just making an observation.
Yeah, of course. I just showed for the benefit of the whole class. That.
Sir, I have an idea of this sum.
Yes.
So suppose if we are taking the root a by b plus root b by a, that one I am taking it as some k, and then by climbing up, if I can prove that the means from there.
Correct. That is there. But then it is 5th degree equation. So you have to prove that only one solution is there. That's the whole point. I mean that is all right. Like what we have done that. So I will call t plus 1 over t because already we have decided. So all of you please. T to the 5 plus 1 over t by 5. This can be written. This is also a consequence of this only. That is written as, can somebody written as a dash in dash? This can be written as a dash in dash. What do you say? Quickly.
So t square plus 1 by t
one
square.
minute, just 1 minute. Like I want precise words. T to the 5. Of course, you can say so many. Just one. T to the 5 plus 1 over t to the 5 can be written as a
5th degree polynomial in t plus 1 by t.
Correct. Polynomial I wanted word is a polynomial. So I think your friend also was saying the same thing, but probably he used more words. So this can be written as a polynomial. That's what you'll have. Of course, degree 5 polynomial in t plus 1 by t. That is of course true. No. That is will get through recursion because t plus 1 by t you take to be u, something u, then you keep climbing up, you will get recursive. That okay, this is this. So it means that now it's a 5th degree polynomial u5, suppose u5, and then u5 you have to get that okay, only one root is there. Do you think here that maybe this might be a tall order to prove that u5 5th order, no 5th degree? Of course, one root will be root 5, so u minus root 5 will become common, but you have to prove still that this u4, which is not very good, 4th power, so you have to prove that nothing comes out of it. Is the plan clear, all of you?
So can you repeat?
Yeah, I'm saying that T5 plus 1 over T5 can be, I'm just telling the heart of it, right? Calculation, of course, you are a master of it. So I'm saying that T to the 5 plus 1 over T to the 5 can be written as a polynomial in T plus 1 over T. That is obvious from this one, right? That's also can be given as a question. That is obvious from this one, right? This one. No, because if it is polynomial, then everything is polynomial coefficient. No, polynomial with integer coefficient or not integer, whatever you write, if base integer. So it can be written as a polynomial in T plus 1 over T. Now, so it means you want, given this value, you want this value, not the other way around. Other way around was easy. Now this way, this is, suppose you say you do not know this value, so you say let's your plan u. So it means this is given. So 5 root 5 is nothing but polynomial in u, that is u5. Something will come u5. Because you have to prove u is root 5, or even not even also, suppose you can guess. So you will write this as after taking this side, you will write u minus root 5 and times something. So this is 4 degree will come now. So my question is this: here trouble should be there. You should anticipate that 4 degree will be there. And so if I can easily prove that this does not have any root beyond it, we are done. But if I can't resolve this 4 degree, then still problem is undone. Means I won't get any more credit. I will just get, say, out of 10, I may get 3 or 4 of 3, 4, not of course the full. So is that clear?
Yeah.
Yes.
Okay. So, and now I will tell you the mystery. I'll connect it. Means of course you can do it also. Say this, it will relate to trigo also. See, t cube plus 1 over t cube is how much? T plus 1 over t. This is your standard result, no? So I need not derive this. This is a cube plus b cube. No, this is all right. Similarly, t squared plus 1 over t squared. That is t plus 1 over t squared minus 2. T4 also you can write. Now t to the 5 plus 1 over t to the power. What is this? See here.
Sir, that is equal to 2 to the power 3 plus 1 by 2 to the power 3 into t square plus 1 by t square minus
1 minute. I'm saying that, can you tell only in t plus 1 by t? I'm saying that, of course, you can derive by your method. You are saying you are multiplying and subtracting, right? Something.
Yes.
Yeah. So I'm saying that, can you tell? I understand. You said that t to the 5 plus 1 t5 is t cube plus 1 t cube times t square plus, and subtract other things and then take care in the end. But I'm saying that, can you guess that what this will be? At least for.
Yes, it is coming that x to the power 5 minus 5x cube plus 5x.
Correct. So good one. So see, I love it. T to the power 5 minus. So it is all odd powers, dear. Cubed and plus 5.
Yes, 5, 3 and 1.
Correct. This you might have got. This I encourage all of you to do later. You will get this easily. It's a simple thing. Okay. By using that recursion again and again, you will get 2 steps. This one. No, this you remember only because this, of course, this you know, because all your life in doing this. These two are your, like, you of course know it by heart. Quickly you can produce. This I recommend that make it your tool book. 7, of course, you derive in exam, but till 5 it is nice. I can give you connection with trigo. See, if I write t is, there is something called e to the I theta. Is there something e to the power I theta, right? That is called cos theta plus I sin theta. How many of you know it? Like,
yes, sir.
Yes.
Yeah, I just want this one. I just don't want any more thing. I just want very simple that t is this notation. It is called Euler's formula. It is I theta. Very deep, but still I'm taking the liberty to write now. So see, this number will be, see, and e to the and this is e to the I theta 3. If you write, then it is exponential. So it is called I 3 theta. So you know it is cos 3 theta plus I sin 3 theta. So this number will become 2 cos 3 theta. This will become 8 cos cube theta. And this will become, see, 6 cos theta. You have got your identity now. Divide by 2. So you know cos 3 theta is 4 cos cube theta minus 3 cos theta. No, here nothing even power occurs. This will usually cos 5 theta by this one, by if you write again and multiply. So they are related thing, right? So here, see, it is easy now. Why? Because after making this u, when you take out u as common, you get 4 degree, but then it is quadratic in u square. That's why your life is easy. You can easily prove. Got my method? The idea that the polynomial that I was talking about, in fact, this polynomial was of degree 4, right? But then after 4 degree, it drops to 2. So u for u square term, u cube odd terms are absent, and so quickly it will factorize, and we can prove easily that this is the only solution, and then we will get this answer correct. Any question on this plan? So I told you that t to the 5 plus 1 over t5 or t odd number t to the power 2k minus 1 plus 1 over 2k minus 1 can be expressed as a polynomial in t plus 1 by t in which only odd powers are there. See, that's the beauty. Odd powers are there only. It again so in 2 cos 3 theta, I will get cos 3 theta, cos 5 theta, cos 7 theta, and all that. In cos 4 theta, you see cos 4 theta, you never get only cos, you get cos sign also. Just check it. Or no, cos 4 theta also you will get same thing. You will get but other thing. But I'm telling you for odd. So this is what this problem is all about. Okay, guys, it's all right. Okay. Okay, let me give you now hint quickly to some of the problems before I wind up. Okay, of course, I'm willing to take 10 more minutes because anyway, you will have few questions as shown by yesterday's session. So see, this is again this one. This is called recursive thing again. See, you have got y equal to, there are two approaches, but both are actually same. One trigo approach and one this x plus 1 over x. And y is this, g is y cubed minus 3y, and x is g cubed minus 3g. So whenever something is there here, I am writing x is t plus 1 over t. Do you have any question it? If I write it, will you not question me? You will of course question me, no? Suppose I say that set x equal to t plus 1 over t. Then first step only will question me something. What? That we have tacitly assumed that life is good. Yes, tell me. If I start my solution that let x equal to 1 t plus 1 over t, then will you not question me? And what
yes,
question will you?
does it fall? Does it
So
not?
because,
We can guarantee that x, y, z doesn't fall
correct.
within.
So you will say
minus
that
2 or 2.
yes, correct. So you will say me that you seem to have assumed that life is good, that x is in need of this form. So it is -2. Nothing lies between -2 and 2, right? Something like that you will tell me. Okay. So okay. So then I have got an argument for that. It will come later. It's a good argument. So say let's suppose t plus 1 over t I write here, and then what it becomes very good. It becomes t plus 1 over t cubed minus 3 times t plus 1 over t. You know it is actually t cubed plus 1 over t cube, right? So from x I came cubed. If I apply same thing on g, I will get t to the 9 1 over t to the power 9. No, 1 multiplied by 3, 3 multiplied by 3, and I reach x. I get t27 plus 1 over t27. Is that clear? This will result. So right now I'm just keeping mum about where x lies. No, and then I will complement it later. So this is this one. And now because x is this one, so I will equate this t plus 1 over t is t7 plus 1 over t is 27. You can multiply throughout by 27. You can see it plainly that either t is t to the power 27 or t is 1 over t to the power 27. You will get like this. Of course, you understand a plus 1 by a. If a plus 1 over a is b plus 1 over b, you will get either a is b or a is 1 over b. This is plain also, and you can get by multiplying also. So so t equal to 1 is common. So it is t26 is 1 because t is not 0, and then t28 is 1. They have only one common root. Only one thing is common, right? And from here I can get again t13. T13 is 1, and t14 is also 1 because this is not -1, right? T14 is 1. Okay. So we get t13 is 1, t14 is 1. They have got only one root common, t equal to 1. Right? This one. Now what I will tell you, this one, that why it will work, that suppose somebody, see this we know how to find solution. This we know because of this thing. What you say, t equal to 1 anyway is the answer. T equal to 1 is one solution. Okay. So see why this works. This, first of all, this is called roots of unity. T13 is 1. So we know how to compute it. So I'm not worrying about it right now. It will give some roots. This will also give some roots. And they will have only one root common, t equal to 1, nothing else. Now see, if somebody were to eliminate something, like see, you start with y, this one, and you put here g equal to x cubed minus 3x cubed minus 3 times this one. Suppose you do mentally, and then x equal to g cubed something. So ultimately the resulting equation in x will be of degree 27. Do you agree? If you eliminate, then resulting equation in degree in x will be degree 27. So you don't expect more than 27 roots. You don't expect more than 27, and you will find that we have got all of them here, and so we can say that okay, it will not. So we can say that okay, it will work. Did you get this idea?
So won't t is equal to -1 also work?
-1 also, yes, it will also work. Correct. T equal to -1 will also work. Because, yes, yeah, it will work because T14 equal to 1. T14 equal to 1, it will come here only, no? It will come here only, T equal to -1. So T equal, okay, but you are saying that if T is -1, so all right, it will work, no problem, no, because this is mod of x greater than equal to 2 from here, correct? So x than equal to 2 or x less than equal to -2. And what we are proving here, that all roots lie in this region only. No, nothing lies in -2 to which we left out. That's what this establishes. We are saying that let us seek roots. We'll say this way: let us seek our roots in mod is equal to 2. But there only we got the number of roots as degree of system, this one, and so no other roots can come. Did you get my argument? This argument. This is also one way to resolve this. That we are always writing this kind of thing. That let's take this and then work out. Just check it later. This will involve little roots of unity knowledge. This one, T2 or 13. And then T plus 1 by T is there. So when you write in e to the power I theta form, no, you will get real things like e to the power I theta plus e to the power minus I theta. Those kind of things will come. Okay. Any question here?
So can you repeat what you said?
See, I first said that write x equal to t plus 1 over t. Okay. And then no, but then if I take t to be real, there is one problem. No, if I take t to be real, then because the x is real, all right, but t need not be real, right? And then of course it is not, no, because t13 equal to 1 has got non-real roots also, correct? Are you getting my idea or not? So see, this will not work. So this you don't do. This I don't want. I just say x equal to t plus 1 by t, where t can be anything. I am saying just x equal to t plus 1 over t, where t can be anything. Don't go into real now t, because that is of course true. And I'll tell you one more solution of this. So you will be that will be in fact effective. In fact, you will find -2 to only all roots, not beside. In fact, in this question you will find, so it is just the opposite. So just guys, don't assume this one. Just assume x equal to t plus 1 by t without thinking anything, t plus 1 by t. Now I am saying by this method, this is my argument. By this method I am getting 20. If I get 27 roots by this x, means just by assuming this, then do I need to look for more? The answer is no. Just like suppose somebody asks you that find roots of x square minus 1 equal to 0. Okay, somebody who does not know this algebra also. Okay, in suppose you ask a child, and suppose somebody he does not know, he just says you that 1 and -1, 2 are the roots. No, or you tell him that see 1 and -1 satisfy it. Okay, they satisfy it. It means now no more can satisfy, no, because we know from fundamental theorem of algebra that it can have exactly 2 roots counting for multiplicities. So once you have found 2, does not matter how you found, you will say that now it cannot have any. In that language, I'm saying it is one of the Olympiad problems. In that language, I'm telling that you are saying I will tell one more method. So this is not correct. This you leave to this mod x argument, because I realize that t is not real. So you write x is t plus 1 over t first. This one, assume x to be this. That we can always assume x is something. Now I am saying that under this transformation, I am getting 27 roots, because I should not get more than that. Why? Because if I eliminate y in turn and then g and x, for example, here g is from here, g is y cubed minus 3y. So this step gives me g means x cubed minus 3x whole cubed and minus some 9 degree you have achieved here. Again, you write x, I will achieve 27 degree. So resulting this polynomial is a 27 degree polynomial in x. So x we don't expect more than 27. We don't expect more than 27, and you will find that this procedure yields all of them, right? And then we can say that yes, this is true. I will tell you one more approach, just because we are running out. One more approach I'll tell you, but that is same thing here, just presenting differently, and it will feel like real numbers. See, x cubed minus 3x you write. Let me just Okay, x1 is 3x equal to, here also I can replace y cubed minus 3y equal to g. Now here I'll write that set x equal to 2 cos theta. I will say, let us assume, here I'm assuming, let's assume the roots are between -2 and 2. Let us assume x to be -2 and 2. X. Let us assume x to be this one, means, or say not assume, say that let's seek roots in -2 2. If I can find in that interval only, it means others no roots are to be found. So I root 2 cos theta. 2 cos theta, why? Because when I write 2 cos theta, I will get here 8 cos cube theta minus 6 cos theta is y. So now coefficient is correct because I can take 2 common. It will become 4 cos cube theta minus 3 cos theta equal to y. So under x is 2 cos theta, we get y equal to 2 cos 3 theta. Theta to 3 theta. And so g I will get 2 cos 9 theta. And again x I will get as 2 cos 27 theta. See, this gives you y equal to cos 3 theta. X is cos 2 cos theta. Y becomes 2 cos 3 theta. Here, second gives you g equal to 2 cos 9 theta. And again, third gives you x equal to 2 cos 27 theta. But we started with 2 cos theta. So again, cos theta is cos 27 theta. You can solve cos A equal to cos B. You can by some two product formula, and you will again get those roots. So just try it later. I hope at least the plan is clear. Actual calculations I can send you later also. No, anyway, I will upload this. Okay. Just allow me to complete one more problem. We are running out of time. Maybe like 3 was the time, but anyway. Yes. Okay. So one final question I will do. These all are easy ones you can do. This one is RMO, our beloved RMO. So of course I will try to do it. See, this is and this is I found 2013 and 2019 or 20 also there is a problem that reads that x to the 90 x to the 2019 or something x to the 5 plus 2019 upon something is rational or some number. So that you try to find. Okay. Here this is really elegant. I will just tell 5 minutes in it. This is really elegant one I found.
Is it x to the power 6 plus 1 by x to the power 5?
Okay. It should be it is 5 only. This is 5, not 6. This is 5. I can check the. Okay. I can check this. This is 5. Yes, it is my. This is typo. X to the 5. Although Olympiad 6 and 5 could have been more beautiful, but if solvable. Okay, so 5 plus 1 over 5, and then they will write here that it is not typo. No, to phrase the point, 6 is not typo. Neither 6 nor 5 is a typo. Okay, so see here again same thing, but here I will tell one more result now. Not result, one more thing that you should know, that if you take AM is say xm plus 1 over xm, this one AM, then AM plus n, right? This one, and no, first multiply AM an rather. AM an means x to the m plus 1 over x to the m and x to the n plus 1 over x to the n. That will become x to the m plus 1. You can see m plus 1, 1 over x to the m plus n, and plus x to the m minus n plus 1 over x to the m minus n. It does not matter which is greater out of m and n, because you see this both have come. This n negative also has come. So I can take, for example, m greater than equal to n, right? M greater than equal to n I can take, right? This one. So am mn you will get as am plus n and plus am minus n. That also I like. Nice. I like this also. That okay, this is good result. That am plus 1. Do you like it by its look? That mn is distribution of m plus n, m minus n. No. Where do you see in life such good distribution that multiply this and m plus n? So now the whole point is that again climb down. No, if I give this is rational, then you can climb up quickly. That irrational, then all are rational. But then the question says, see, remember our question. So now this is that these two are rational. 4, obviously only from 4 you cannot reach, that is clear. Only from 1 you cannot reach this one. No? Inconclusive it will be. So they gave some two things. So they said that okay, A4, they said A4 and A5 rational, and they want you to climb down and prove that A1 is rational. That's a good problem. Converse, of course, is an easy one. That we did also converse. No, rather contradiction we did. So A4, A5 implies A1 is rational. So for that I gave you this kind of lemma, a small one, that okay, this you use often. So the trick lies in choosing different thing, right? See, and then a special case is very good. M is n. M is n means A2m is am square, rather am squared. Am squared is A2m plus A naught is anyway 2. A naught is 2. A naught is 2. Right. So A2m equals am squared minus 2. So if m is rational, A2m also is rational, right? So A4, A5 rational implies A8 and A10 also are rational. This is first good victory. That is rational. Now, can you tell me what to choose some other things, good things in here in one, so that I get some useful relation? Remember, things are given to be rational. So just tell what we choose. I also chose
Sir, I was approaching in a different way. I thought that x to the power 4 plus 1 by x to the power 4 into x plus 1 by x equal to x to the power 5 plus 1 by x to the power 5 plus x plus 1 by x.
Correct.
I
So
mean,
same thing. You are writing T1, T4. You are doing same thing, T1, T4 without realizing. Are you getting?
yeah.
You
So
are doing
right hand side is rational, so left hand side will also be rational, like that.
So it will not come in one step. I mean that, of course, you can multiply that. So I'm saying that you are actually doing this one. You will be doing this only. That is why it's like, no, in Sanskrit, no, I'm giving sutravakya to you. No, that this is what at the heart of it. This is what you should carry you after all, because these problems will keep changing. But this is something learning will not change. So that's so. Okay, now let's see by quickly. Let's see putting here. Let's put here 4 and 2. Let's check what you get if you choose 4 and 2. So A4, A2, that you get to be A6 n plus A2 only. See, I cleverly choose such numbers such that n becomes m minus n, good number. N can never become plus, n is m minus n. Means if you take m as double of n, then something good you get 4, 2. Because your say your actors are contained. You have, it's not a multi like, it's not a blockbuster film, not multi, many. You want few actors, no? You don't want suddenly A4 also come, 5 also come, 10, 8, 11, all. Then they will make your life difficult. You want them to keep as few as possible. So you choose M clever 4 and 2, so that this is again closed. 4 minus 2 again becomes one of them. So 4 minus 2 can never become this one M and N. It will become a smaller only. So this is 2, A6, A2. Now you choose 8 and 2 because 2 has already come. A8, A2. That is 8, 10, because I want 10 also. See, 8 also is my hint. No, 8, A4 I want to involve because A4. 8, A2 is A10 and plus A6. Correct? This you get. Now A4 you know to be rational. This is coefficient like A4 rational. A8 is rational. A4, 8 is rational. Correct? And A10 also rational because A10 we got. So I write cleverly as, think this way. Now it is here. This A4 is like coefficient for me, A4. So I will write like this way. I will write in bracket. This A4 is like my coefficient, A4, A2, A4 minus 1. See, this is minus 1 will come. Here also you have to argue correctly. A4 minus 1, A2, and minus A6 is your coefficient. And here A8 is the coefficient, A8, A2, and minus A6 is A10. So these are all coefficients. These A10 all are coefficients. A10 also is coefficient. So these all are rational. These all are coefficients. And this A2 and this is our actors. Now, when will A2, A6 will rational? Because all are rational. Will it be rational? All are rational. So is it not that it will be rational? A2, A6. Why? Because yes. Why it will be rational? Why A2 and 6 are rational? Because coefficients are rational. Please quickly someone tell.
So we can subtract both the equations, right?
Yeah, I will not subtract right now. I'm saying that, okay, I'm saying that, can you say here only that they're rational? I've got a purpose to ask, so please answer. Can I say here only they're rational? I cannot say here only. I need to do some more work. Means all.
But here both A2 and A6 are there, so how can we tell that now only that both of
1 minute. That's what I'm saying, that all coefficients. Okay, now you are coming to what I'm asking. I'm saying that this is, think of this as a, of course you can see, I always want to give you more. No. So I am saying here that of course you can subtract, you can find A2 and A6 explicitly only, not a problem. You can find. I want to teach something larger, something of larger importance. I am saying that now, as a system of linear equations, listen me out, in A2 and A6, the coefficients are rational. Does it guarantee automatically that A2 and A6 are rational? If no, why no? If yes, why yes? So now you say, someone was saying that, no sir, how can we say? Is my question clear or not clear? That this is a system of equations in A2 and A6 with coefficients rational. Does it
Is
guarantee
the other
that
the other terms other than the coefficients can be irrational? So
oh no man, what this all is unknown. A2 A6, that only you find. This is A2 and A6. Other term is what? Other terms are there. It is A2, it is equation in A2 and A6. Now A2, some number you are doing something. This is 4, 11, 18, whatever, I don't care. I'm saying A2, A6, and here it is can be 0, not 0, but all are rational. I'm saying if these all guys are rational, can I say A2 is rational? The question is complete. It can be answered.
no, sir. We can't directly say.
Okay, so what we need to say? What we need to what one more? You are right, but what one more thing I tell you, then you can say yes. Now they are rational.
At least one among A2 and A6 is rational.
No, not at all. I just need to say that determinant of this is non-zero.
So maybe that the equations are not same, like they don't break down to the same equation.
No, listen. A2, A6, see coefficient are, this is the point, understand, A4 minus 1 coefficient. I need not tell, this is coefficient in -1. Say it is 11, 18, A4 minus 1, it is not 4 minus 1, it is A4 minus 1, means, so I will write like that. This is a coefficient. Here coefficient is 8 and -1 coefficient. This is coefficient, and A2, A6 are numbers. 0, I don't care, 0 comes or whatever, rational comes here. No, 0 comes in your life. See, you can always do by subtraction. I am trying something different. Please understand. Okay. So I am saying that these coefficients are rational. It is a system of linear equations in two variables. The coefficients are rational. Okay. If I multiply the cross thing, like this is like a1x plus, not say a1, because a1 you may take this one. Suppose it is lambda 1x plus lambda 2y, and mu1x plus mu2y is here nu1 nu2. I don't care these numbers. If this is not 0, lambda 1 mu2 minus mu1 lambda 2 is not 0, as long as, then I don't care. Then x and y are solvable, first of all. And if these are rational, then x y also have to be rational. Is it clear?
Yes, sir.
Determinant what I am saying, so you are afraid, so don't worry. I'm just saying this one, that in linear equations, the cross term, look at my arms, it is the cross terms, right? If I multiply these two, this times this minus this, if this is non-zero and all coefficients are rational, then xy will be rational. That's what my claim is. That is true. That is a true statement. So here so that is determinant only we call sometime A4 minus 1 and this one in.
If the determinants are zeros, then the line will be parallel.
Yeah, correct. So correct. So if it is non-zero, so that is geometry aspect. That is good only. So we are just saying that I'm making again Sutruvak statement. I'm saying that if det is not 0, then all coefficients are rational, then A2S will be rational, and that is correct. Right. That is very easy statement to prove. And then why this is. Now see, now multiply this A4 minus, last step, A4 minus 1 times this one minus 1 and plus A8. That is your coefficient there. So this should not be 0. I have to verify this is not 0. So A8 minus A4 plus 1 should not be 0. And what is A8? A8 is A4 square something. See, A8 is A4 square minus 2. So you get A4 square minus 2 plus 1, A4 square minus A4 minus 1 is 0. Right? Correct? This one? A4? Just check it. No, this is plus 2, I think. A2m is, A8 is, minus 2. So minus 2 minus 1, A4 square. Now, but yes, so here, but here you are finding A4, this one. You are finding here that I had hoped that plus 1 will come, but anyway. So, but A4 is, of course, this one. A4, see, A4 is rational. A4 is rational anyway. A4 is rational, correct? A4 is this one. But here it is irrational, right? So this is not 0, correct? Do you agree? Here this is not 0, yes, this one. And so A2 and C will be rational. If you subtract also, you have to argue this. This will not leave you. This will come to haunt you. Means the moment you multiply everything, then suppose you take A2 times something is something, then when you divide it, you have to prove it is not 0. That is same thing will come. Of course, that is same thing will come. Yes or no? If you want to solve for A2, something upon something will come. So you have to prove not rational. This is not 0. So that is achieved because A4 is rational. No, and here if you solve for A4, you will find A4 is irrational. If it is imaginary, then of course no need to do that also. So A4 rational. So it means this is not 0, and so you got A2 A6 are rational. And then it is okay. If A2 A6 is rational, then you can get A1 also. Yes or no? Got it? Because last line will be that you put 5 1. So A5 A1 is A4 plus A2. So we have got A2 rational, you have got A4 rational, A5 anyway was rational, right? And so A1 becomes rational, A5 rational and not 0, because not 0 given. They have given not 0. Both rational and non-zero not given. But non-zero should be given. Let me check the original. Non-zero should be given. Or you can prove it this. You check it later. That. But then when it can be 0, suppose it is this one, then it cannot be 0, no, because real number. Non-zero and no, non-zero real number should be non-zero real number. So anyway, this number, this A5 cannot be 0. You have to argue these things in subjective exam, because this A5 to conclude that A1 is of course A4 A2 already rational proved. No, right now it came. And then 5, no, this is 6. So A6 A2 proved. A1 of course A5 is known, not 0. So A1 I can prove that A1 is rational, and that you just check it later once more. If anything is there, please let me know quickly. If anything is bothering you here, in some larger point, not the actual calculation, that you can, of course, you are smart to do it later also. Yes, please quickly, 1 minute. Guys, be frank. It is your class, not my class, right? You have to understand better. My job is to deliver. So I just repeat, this was at the heart of it. But then you have to take care of all those small things. These are important details. Otherwise, you get just 0 marks out of it. It happens. Like in these questions, we see many people write so many things, and then after the results come, then I have also got calls from many students and saying many exams or other thing also that we did this, like, but we have all got, like, OISA nobody got more than this, here nobody got more than this, like that. So this happens because that you miss out on important details. Okay, so I repeat that we wrote AM, this one, then we wrote AM n is this one, m plus n. I choose clever values. One good value was that don't make this mn, m plus n, m minus n, don't make all of them distinct, keep some of them same. So anyway, mn will be distinct, then this is distinct, you can't choose. Only m minus n you can control, and that also I can pick at larger, smaller one. So m minus n is n, a smaller one if you choose. So that we choose some suitable values. So second point, so that my house is contained. I don't have more actors in the play, because again I have to deal with them. So A4, A2, A6 came. This, so I took 4, 8, 4, 2, 8, 2, and then I take 5, 1. And one small detail was that I proved first of all A2, A6 are rational. So even if I don't do my method, you will solve for A2, no? Then you will get A2 times something is not 0. A2 times something is some number. So from there to conclude, you have to prove that this is not 0. Otherwise, you can't say that A2 is rational, because this will come. You have to prove non-zero. That is important, very important. So that this only will come to haunt you. This only A4 square will get. Whatever you may do it, this will of course come. It's just like this one. It's just like this one, that if you solve, suppose ax plus by is c, a1 is b1y, and a2x plus b2y is c2. Whatever you solve it, x upon and y upon this 1 upon a1 b2 minus a2 bn of course come. Yes or no? This will of course come. This you cannot get rid of it. You multiply by a2 whatever you do. No, because and then this, because this goes up, you don't care about this, you care about this one. That's what I'm saying, that this should be not 0 to conclude, because then you will say rational, because rational upon non-zero decimal is correct rational. So this is what I'm trying to make. And then I'm saying that don't solve it. I was just asking you, don't solve it. Just look at the coefficient and find this cross num thing, a1 b2, this one, a1 b2 minus a2 b1. That's the good way to argue, a1 b2 minus a2 b1. If that is not 0, then all you are done. No need to calculate. No need to keep doing that solve. They did not solve you. They just wanted to show you that A2, A6 are rational. And then last step was again A5, and then you will get. Okay, so today I exceeded the time limit, so I'll just I will rest my case. If anyone have a question, Sanchayan can, or Ankan, who is in the session, they can tell the students to ask if they want to ask anything.
Yes, you are free to ask questions. You can unmute yourself and ask questions.
Even you can ask questions beyond this also, not necessarily of the lecture. Anything that is troubling you, some advice or something.
Sir, please give us some advice that how to be a better problem solver.
Okay, so that is of course okay. So the point is that, see, of course, do lots of problems, but don't do very inaccessible problems. Like, always do, first of all, see, if you do very inaccessible problems, no, suppose you directly go to IMO shortlist, okay, or it is different. So first do those problems which are little beyond you, not much beyond you. No, like you can, it's like that. If a child is there, no, if you tell him, then he will he can raise his hand, and he can take a ball from the shelf, or he can just stretch himself. No, he can jump. No, but then again, you don't have to give him the height of the ceiling, right? So slowly you have to increase. So that is very effective. It's called in weight training also. See, weight training what does? So don't do very easy problems also, and don't do very challenging also. But then it is like a staircase approach, like slowly. In weightlifting, there is a rule called 1 kilogram rule, that each time you increase by 1 kilogram. No, it is better to, it will be really good to like lift a weight of 10 kilogram at once. But then 1 kilogram first you do so many times, and then you will have. And then do this thing also for you. I do it all the time, that try to find similarities and differences between the problems. No, that okay, this problem, what is similar, what is difference, what is different, and then take something out of the problem, not the problem itself. For example, this will go in, suppose I were a student, this will go in my notebook. AMMN is AM plus, and this one, and then how I am trying to contain, because next time you can change, A6, A8, whatever they can, something they will give. So this should stay with you. So means first make your notes. It is useful for anything, not only for your INMO or RMO, but any exam that you take, because however hard we try, exam is a reality of life, right? You have to write so many contests, so many exams you have to write, right? So the point is that you have to be effective problem solver. So you have to really write something, so that writing means that you are just giving it a separate status, so that it is registered in your mind, right? You are giving it some honor, so it stays with you. Otherwise it just flies. You will just remember that, okay, something like I did, something like I did M plus N, and something I did, and then I did something. That only I will remember something. And then in exam you are trying to recover that what that something was. Okay, and then you may panic or shiver, and then you may not get at all. So that is one thing. Second, do lots of problems. Start with this one. Do all the, for example, Olympiad, do all the RMO problems. 10 years at least you do, 10 years. And INMO. And check all solutions, all badge. Because your solution may be good sometimes it may be not good, but then from others you will learn much more. How are they writing argument, because they're written by experts, right? We take all the effort to trouble to write it. No, we pause about every comma, everything that real we write or non-zero we write comma or not right or full stop. I mean that a real math person will always worry about such things. So second advice is learn from the masters. Don't read from the crap books, right? Many market books will be there. No, this all, I don't want to name publications. No, XYZ publications, that thing. They'll all be copies of, they are copies of copies. They are not even copy of original. Then I would read it. They are copies of copies. So I at least want to read original or copy of the original. If I can't read Shakespeare, can't read, then of course I will read someone who is an authority on Shakespeare. Not anyone market person who will just write something. So be very conscious, because time is limited. And then for other thing, you can go to some national contest also. They're really good. Britain BMO contest you can go. Okay, Canadian contest you can go. Canadian have got solutions also. BMO does not have there. Okay, so many. So and then don't spend more time on social media like AOPS something, because there of course you will read something, but then for reading one good thing you have to read 10 bad things also, right? Somebody will write his comment, oh I did not get, oh I got, oh this happened, that happened. Okay, you want to cut through all the clutter, right? It is for the people who have got a lot of time. You don't have time, so use it with discretion. You know what you're looking for. You go look for and then come back. Don't get dragged into it, right? So that's so this one. Do more problems. Do from respected sources. Don't spend much time on the problem. It's not that you are spending half an hour on a problem in the beginning. Okay, because spend 20 minutes 15 minutes something. If you don't get the idea, then look at solution little while and just peek at it. And if you get that, okay, he is starting the recurrence, then you close it and again start recurrence. If you don't get, then again see. But make sure that at the end you learn, because you don't have time. This one, you cannot think for weeks about a problem. Phil Smithley say that they thought about weeks and weeks. Newton used to think for 2 years about a problem, right? It is said he could hold his mind. No, but then the point is that it depends on what our objective is right now, right? So right now we know that all of us know, including me also, anyway, but anyway, you of course more, okay, that you know that, okay, that right now there are so many things to learn. So there has to be a balance between when to see solution and when to not. So you will know that, okay, you hit a wall now. So let me check if there might be some new grain of idea which I might not know. And sometimes it will be, oh no, I knew it, but still I missed it. That also is good. Then you will say, okay, next time you will tell your mind, okay, next time I'll remember this. Next time you will train your mind. Remember. So sometimes you may get different ideas. Sometimes same ideas, but you will miss. That you have to worry about more. Okay, any more thing?
Thank you, sir. One more question. That is, I once solved a geometry problem that came in INMO, which had two parts. That one part of which I could solve just within some minutes. That using somewhat a trick, and I could solve that. But using the same trick, or using or progressing similarly, that the problem was like somewhat. Do the first part and henceforth prove the second part, and I just proved the first part, but proceeding in the similar fashion, I couldn't do the second part, and it was tremendously hard. But one of my friend just did the problem, and he did the first part, and in the similar way he could do the second part in some other way. But so how to choose that, whether I should progress in this manner or that?
See, you are saying about some specific problem. So that I think you can write. You can just email me. What's your name? What's your name? Can you hear me?
Yes, sir. Yes, sir. My name is Inish.
Inish, so you can email me. I will just check that what you are saying. But in general, I will say that in general, in beforehand, you cannot know. No, you cannot know that which method is going to work. Okay, it's like that. Okay, you may have some inkling of it, some idea of it. Okay, so sometimes it may happen that for two different parts, you may have to employ different methods. That happens. Okay, so that probably you can't tell before. But if you, that depends on merit of the case. So you may write on my email ID, then I can check it that what you are saying about. But anyway, what happens that we need to check that you cannot answer it like one side does not fit all, right? That's what I can say right now.
Yes, sir. But I was just asking for just a general thing that should we proceed in some not for a just a specific problem, that was only a specific one that came in.
Okay.
But I want to ask that is there any general trend that we should progress in this way while we see this one is to be proven, or something like that, that we should prove that?
That depends. That also depends on the problem. That will depend, because sometimes suppose there is some question on combinatories, then it is sometimes you look at a question, you find that it is recurrence asking. No, sometimes it is coloring argument. So that is there in all the subject, in all the topics. There are some standard techniques that you can quickly get to know. It is stars and bars. No, it is this one. So, but sometimes it won't come also. If it is coming, then of course you use those methods.
And can we achieve that by practice?
Yeah, of course we can achieve. Like achieving practice is very important. Like by practice, why? Because IMO level, of course, I would say that, okay, that is, of course, only practice won't help. Okay, but then practice, of course, will be helpful many places. In fact, I don't think till INMO there is any problem. Okay.
Okay, so thank you very much.
Okay. Okay, Sanchayan, then we can. Sanchayan is in the meeting, or someone else? Like I don't.
No, sir, I'm Venkat. Sanchayan just left.
Venkat, you are holding. Okay, good. Venkat, so I think I'm delaying you. So Venkat, you can now formally end the meeting.
Yes, sir. Thank you very much, sir.
Okay.
So I'm going to end the meeting. Thank you.
Thank you, everyone. It was wonderful to again interact with you all. So may you all do well. Okay,
Thank
bye
you.
then. Okay, bye.
Yes.
Okay,
Bye.
okay, bye. So you can end the meeting now.
Yes, sir. Okay, sir. Thank you, sir.
Okay, welcome.